Welcome back, everyone. Once you've created your graph and added your least squares line, we want to think about what this actually tells us. What is the trend over time, and how strong is the trend that we are looking at? Is our sand volume or wave characteristic that we're looking at really changing over time? And if so, by how much? Within our trend line, there are a few different things that we can look at. First, let's start by looking at the slope of our line. Is the trend line trending upward, downward, or staying pretty flat? This can visually be seen by taking a look at your trend line, which you can see in green here on our graph. But you can also interpret it quantitatively by looking at the equation of your trend line, which will appear in the yellow box. The number before the words cubic meter per year will signify whether the slope is trending upwards or downwards. If it is a positive number, the factor would be increasing over time and will show an upward slope. And if it is a negative number, it will be decreasing over time and show a downward slope. So here I have the number negative 99.4 cubic meters per year, which indeed signifies that I have a downward trending slope, as you can see in the graph above. The closer your number is to 0, the flatter your slope will be, or the smaller increase or decrease that you'll see in your slope. And the further your number is from 0, that will indicate a steeper slope or a larger increase or decrease. Next, we can look at how well our data points fit the line. Is it very varied, or is it close to the line of best fit? To do that, we take a look at the r-squared value that we have below our equation, which you can again see in the yellow box. The r-squared value will be a number between 0 and 1, with values closer to 0 meaning that none of our data points fit the line and it is more random, and values being closer to 1 meaning that all of our data points fit perfectly on our line, creating a perfect steady trend. For some of our data, the variation of our data can be very high, as sand volume can be affected by different characteristics such as wave characteristics, and then wave characteristics can be affected by other things such as storms or tides. So keep in mind that variation is not necessarily a bad thing though. When dealing with environmental data, variation is common, and the variation doesn't mean that your data is wrong or that you don't have a trend. In the case of the data that I'm looking at here, the trend line has an r-squared value of 0.04. This is close to 0, but it is not 0. So some of the points can probably be explained by the downward trend that we see. It'll be up to you to think through these factors as you look through your data and decide what trends you think are happening. Go ahead and take a look at the slope of your line and the r-squared value of your data and answer the questions on the following slide.